Can you hear me? Hello? Can you hear me? Does it work? What's this, please? Okay. So, good morning. We can start this session. Just remind me, we saw all this. Yeah, there is some background sound still, or is it okay? Not okay. Which background? Please, for the other students, can you hear the same noise, the same background? Yes. What does I can hear some students' voices. Okay. So what can we do? From outside. You can reduce the microphone. Yeah, maybe. Problem is that they are not disturbing me. Okay. Yeah, but you will see when I start talking, you will forget them. Okay. Let me check if all equipments are working. Yeah, I can write. I can do anything. Good. So before we proceed, just tell me if something is not clear regarding this scheme. You know, the scheme of biometric. This is the general scheme. If you have some questions, so just ask now. I told you that it's very, very important. Everything, all the program is based on scheme like this. Do you have questions? So anyone can make the difference between verification and identification? Yes, if I ask this question to anyone? Not for you. So just tell me what is not clear. Watara, if you can just say something. It's clear. Okay. So everyone can make the difference between verification and identification, right? You don't have to hesitate 1 second when we talk about identification and verification. At any moment, you can say, this is the difference. If we give you any project, you can directly see if it's an identification or a verification. Okay? The second thing, you should be aware about the enrollment phase. Okay, when we enroll someone. So is it clear for all people? Enrollment. Okay, enrollment is the first time when you register yourself in the database, or maybe the administrator do this for you. Okay, this is the first time where we extract a signature from or biosignature, and we store it in a database. Okay, all these keywords are very important, and I told you that electronics very important to capture data, image processing very important to pre-process images and to extract features, and after this you have computer science to manage database, including classification methods and decision methods. Okay. As I said, very soon you will start some classes on extracting features, okay, from images or even from signals, because when you take classes about extracting features, you can apply the same approaches to other applications. And you will take classes about classifications methods. I told you this. Not just theory, but you will do some labs, including, as I said last time, neural networks, methods like SVD, and also machine learning. You will take some classes in machine learning. Okay, it's very important, you know, to deal with all these materials. So I gave to you some examples. This is for face analysis. And here is just a slide, especially for people who are interested in biometrics, but from a different point of view, not for security purposes. As I said, biometrics can be used for in different fields. And always I ask you to remember bio and metrics, measurement, okay, and this is bio, okay, and this is for the measurement. So in fact, if you take, for example, images like this is a US image, ultrasound image. So how can we apply biometrics on this kind of images? If I give you just an image like this, and I would like to apply biometrics, what can we do? Think about measurements. So you can measure, okay? You can just measure. Maybe sometimes you have to measure, I don't know, distance or different distances, you know.
Or even in ultrasound you can measure the depth.
Of course, yeah. Okay, you can achieve some measurements like this, and you extract some features, and you say, okay, this is alpha, and this is beta. You can maybe measure, I don't know, maybe the heart is here, and you have to measure, you know, the surface of some region of interest. Think about always RIO, which means region. I try to write it, but it's not that easy. What's this? Region of interest. I have a problem with this board because I used to use it with Mac computers, and I noticed with Windows here it's not working properly. Just maybe next time if you can just check calibration, yeah, because I'm quite sure it's not normal. You know, I cannot write. Okay, sorry for online students. I wanted to write region of interest, but it's very difficult. Okay, so as I said, you have a medical image like this, and if you start measuring some useful distances, okay, for a given application, So it's a biometrics, okay? And sometimes you can be interested in analyzing or extracting features from one region of interest. So you define the region of interest, and after this you can start measuring, extracting different parameters. For example, you can measure the area, which is here. You can model the shape. You know, we can model the shape of any region of the in the image. Okay, so this is the ultrasound image, and this is an MRI. You know what's MRI? What does it mean? All people they said yes, but MRI, magnetic. Don't type in Google. Yes, it's magnetic resonance imaging. Okay. At the end is imaging. No. So here you have an MRI, and in some cases, what can we measure? Can you tell me what can we measure from images like this? What can we measure from images like this?
Also distances, maybe.
So you see here the brain, okay? And depending on the application, you know, because it depends on the application, it depends on what you are looking for. Yes, if you are looking for tumors, something in the brain, you have to define the region of interest, and you say, okay, I have a problem here, and you start measuring. Maybe you can measure or model the shape, and after this you can start, how to say, you can measure some distances. So it depends really on your application. But each time, that's why each time you notice that I'm using the word measuring, I'm measuring something. It's just to make the connection with biometrics. Okay? So my question now, yeah, before the question, this is the last example. We saw some applications on iris recognition, okay, for normal subjects, and here it's an abnormal subject. So what can we measure here? What is abnormal for you here? Center.
The yellow color.
What?
Black dots.
Black.
Black dots on the
Black regions. Yeah. Okay. Here once again, the physician can take a decision depending on what he's looking for to extract some features, to measure some regions. So if the pathology is basically in the iris, okay, maybe he will be interested in extracting some, you know, these features. Maybe because it's okay. Compared to the other biometrics, you know, we saw for normal subjects. Do you remember what was the method? Do you remember when I talked about iris?
Pigmentation.
When we talk about biometrics for security, remember, you have, this is the iris, okay? And the idea was to extract this region. Our region of interest was this. And we transform it as an image. It's like we unwrapped, you know, the image. We open it. Yes? And after this, we start processing this image to extract features, alpha 1, alpha 2, alpha 3, and so on. And I use for normal subjects, there are some methods, well-known methods, using Gabor filters. So here, it's a kind of biometrics for security, and also for applied on normal. We call this normal subjects. Okay, there are no pathologies. So for security, you have to use, of course, the scheme that we saw before. Pardon. You have to use this classical scheme, which includes enrollment, phase, pre-processing feature extraction, matching, and the test phase. So now, I go back to the whiteboard. So, okay, this is for the normal subject, and for abnormal subject, for in the medical field. My God, I'm writing. I'm suffering with this pen. Medical. No, I can't. Anyway, you understood. Okay. As I said, at the beginning, you have to define your region of interest. Here, the region of interest was here, right? And when you deal with medical images, and based on the example we saw here, I mean this one. So, as I said, this is the region of interest, and the idea is to extract some useful information, maybe because the pathology is located in some specific areas. So maybe in your application, the purpose is to count these regions, and also you can measure the area in each region. Okay, so what can you propose as pre-processing methods? How can we highlight or extract just these regions? What can you propose? What I want, what I'm looking for is basically to extract these features, these regions. So at the beginning, you have an image like this, you see, color image, but you are interested only on these small regions. So in terms of image processing, how can you start? Pardon? Grayscale? Oh, okay. So at the beginning, the image is color. And you say, okay, I'm not interested in the color, so just make it grayscale. Okay, good. Next. What will be the next? What Utara said DFT. DFT, in fact, which means discrete Fourier transform, is just a transform to represent the information differently. But directly thinking about the DFT is a tool. You have to understand this. If we talk about DFT, FFT, wavelet transform, all these are image processing tools. But I'm talking about the idea, general idea, and after this you can think about the tool. You have to make the difference between what you want to do and after this the tool that you should apply. Okay? It's like one person is located in region A and wants to move to point B, and we say, okay, the purpose is to move from A to B through the point C. This is the purpose. And now, if we ask you how, you will say, yes, from A to C, I will take metro, and after this I will walk. So here you explain how you will reach the goal. So first you have to explain what you are looking for. So you have to make difference between the tools and the objective of processing. Okay, so we said here you start from color images, you transform it to gray images.
After that, the thresholding will serve a good because the point is much darker than the other regions.
Yeah. Here, if you analyze textures, probably you will notice that here these regions are darker, you know, than the other one. So you can think about many methods of segmentation, including thresholding or something like this. If you have a very high contrast, thresholding maybe, you know, in some cases with thresholding it doesn't work properly. But the idea is to segment your image. When we say segment, it means you have to define regions. And you say, I am interested only in this segment. So normally, when you use a segmentation method or any filtering method, the result, what will be the result? You will obtain only the regions you are looking for. So maybe based on the method you use, maybe you will obtain all the regions will be black, like this, and the iris will be in white color. And you say, okay, now I have isolated, okay, the different region of interest. At least you say, okay, now I know what I'm looking for, and my region of interest is here. So I don't have to focus on this region because I have everything here, and it's in black color because everything which is not interesting for you is in white color. But you can invert, of course, the color. It's not a problem. It's just to say, I'm interested in this one. This one, I will make it in black color, and that's all. Okay, good. So from here, you will obtain images with just some shapes. Now, what will be the next step? So, as I said, think about the objective, the purpose, and after this, you have to think about the tool that you have to use. You say, I want to filter my image. I want to segment my image. And after this, I ask you, okay, which tool you will use? And you will tell me, in this case, I can use just a high-pass filter. I can use this segmentation method. I can use this thing and so on. Okay? So when you obtain something like this, what will be the next step?
Directly we use filter, so we convert into digital form.
You can convert to?
First we have to convert what we have got into digital form, then we use filter.
Yeah, but filtering, you use your filters in this phase because you will filter, you will segment, you will use threshold, basically to obtain something like this, because this is what you are interested in. You are not interested on all these details. So that's why the filtering and segmentation or even transformation can be achieved in these different phases until you obtain at the end one image which contains only your region of interest. Okay? But yeah, Nitsa here says, yeah, we measure and calculate. Yeah, now, since you have the different region of interest, now you can start doing anything you want. You can start measuring. You say, okay, I have how many, you can count the number of regions, and you say I have 4 regions, and you will call region 1 is located at the coordinates, you can give the coordinates, okay, of this region, so X, Y. What else? What can I add? I can measure, okay? So you can extract, when I say measure, it means you have to extract some parameters, alpha 1, alpha 2, alpha 3, and alpha 1, alpha 2, and alpha 3. And here you can say you are characterizing this region. Okay? Why? Because I know its location. Okay? And I have also extracted characteristics. But you can make the signature different. It's up to you what you want to extract from the region. You can measure anything you want. And you can do the same for region 2, region 3, okay, and region 4. And after this, you can even fuse all this data in one vector. You call it R. Okay, and here you can fuse all this data. Maybe you can put them in a matrix or maybe a vector. It doesn't matter. The most important thing is to say this image is characterized by this matrix. This image is characterized by this vector. And matrix or vector, in fact, will be regarded as signatures, right? So you say, I extracted the signature. Signature from what? From this image, which is an abnormal image, and we can say this is signature. This signature is for this pathology. Okay. Is it clear? Now, once you extract the signature, what you can do with? What is the purpose? Always you have to think about the...
Identify this pathology.
Pardon?
Identify this pathology.
Yeah, you can maybe think about identifying the pathology. And if I ask you a question, is it possible that you use the previous... Can you use the previous scheme, you know, the general scheme? Okay, so this is a generic scheme for face, and now just I ask you to use it for the medical field.
Yes, actually the same thing happens, but two different things. First of all, enrollment will be for pathology instead of the person. And the second thing is the feature extraction, because we invested in different features when we talk about pathology.
Okay, so instead this face, I can replace it by what? I will replace it by the pathological iris, okay? Anyone? I observe one special case, and I say, okay, this image, this iris is, or this eyes contains some pathology, and I would like to model, to characterize this pathology. Okay, so the input here will be just the first image that you capture. It's like enrollment, because just I want to learn something about this pathology. I'm just learning. Okay, you learn, or you make your computer learning. So the input will be any image containing pathologies. And after this, you have this block, this step, which is image signal pre-processing. So this is what we said before. You can extract all the region of interest, and after this, you extract your features, okay, or you extract the signature. Remember here, this signature I was talking about. So in this phase, you will have a signature here, and I will store it in database. So for security, remember your database, I have in the table, I will put here as an entry the name of the person, remember, and his or her signature. Okay, here it will be a little bit different, because it will be the name of the image. That's all. Okay, and you add here its signature. So it may be even a pathology, because how to say, the physician, when we provide to him images like this directly, he can say, yeah, probably it will be something like this is the pathology. So once we extract the features, we can how to say, instead using as entry the name of the person, so maybe we can use the name of the pathology. Okay, associated to its signature, and it will be stored in the database. After this, we can imagine another enrollment. The physician will use another iris image, maybe with another pathology, and it will be known, because when the human, especially if the expert analyzes some images, yeah, directly he can say, yeah, this is this pathology. Probably it will be this pathology. Okay, so the physician is here. We present to him one image. Based on the image, he says, yeah, this one is this pathology. And after this, we extract features, and we extracted signatures from this image, and we store it in database, and we say this pathology number 2, this is its a signature, and so on. So we are enrolling not persons, but we enroll different cases of pathologies. Okay? And at the end, you will have in your database maybe 2, 3, 4, 5, 10 different pathologies. Okay? Each pathology with its signature. Good. So right now we notice that for the moment we use in fact the enrollment scheme. It's like in security. Okay. Now, can you explain to me the second phase, this one? What will be the scenario? The first step, it was like a training, you know, just we enroll, we observe, we extract signatures, and we store in database. That's all. Okay? Now, what will be the second scenario? Pardon?
New patient with new photo will go through feature extraction and compare with different templates of different pathologies, and the system will try to identify which pathology it is.
Exactly. So you understand now for the test step, it will be a real patient. Okay. So we capture the iris. Okay. We extract some features, and we extract a signature, and after this we have to make a kind of matching with what we stored in database, matching including all different of classifications, right? And here, what will be the final decision? What will be the final decision? In biometrics for security, we say, if it's verification, we say yes or no. If it's identification, we say this is this is the identity of the person. And here we have something different, and we are using the same scheme. What will be the result? So once we have, you know, we capture one iris, we process it, we extract features, and after this we compare. What will be here the output?
The name of pathology.
Yeah, it may be the name of pathology. If it's an identification, it means we capture one iris image, including pathology, and imagine we don't know what is this pathology. We don't know what is this pathology. And we inject this image in our system, and this system will say probably it should be this pathology. It looks like. Okay? Even if the final decision here should be the physician. But this system is basically to assist physician. In the medical field, we use this kind of systems to assist physicians. So you see here the identification. At the beginning, I don't know what is the pathology. Just I use an image, I extract features, I use classification method or decision technique, and at the end I said probably it is this pathology. So here once you extract your signature, this signature will be the input of a classifier. Okay? And the output will be the pathology. Maybe you have here one pathology number 1, number 2, 3, 4, 5, and so on. So if the features that you extracted look like some features corresponding to some specific pathology, so here you will have as an output, you know, for example 1, 0, 0, 0, 0, which means you identified the pathology. Okay, so here the idea was just to see or to make the difference between identification in security and identification in the medical field. Now, if I ask you the question about verification, what will be the scenario for verification?
The physician will know about a specific pathology and will ask the system to prove that this is the pathology or not.
Yeah. Here, if we think about verification, so here the user should say, it's this pathology. I'm sure this is, this pathology. And the automatic system will say, yes, or I don't agree, no. Or maybe, in some cases, especially in medical field, we have a third output to say, tell me,
50%.
not 50%, or it may be, I don't know. I'm sorry, I don't know. Why? I will tell you why. Because it's very important, you know, to have an output where the automatic system says, I don't know. It looks like this pathology at 90% and 10%. Yeah, you can do something like this. But because, you know, it may be risky, you know, if you say it's for sure, it will be this pathology. It doesn't work like this, you know. Sometimes when we say it will be this, it looks like this pathology, and we provide a kind of percentage, you know, just to say if we are sure at 5% or 90%. And in your system, sometimes it's important to say, I cannot classify this pathology. Okay, I cannot classify this pathology. So it's up to you when you choose your classifier. It's up to you to decide how many outputs you need in your classifier. Because you have to understand that, you know, decision or all the results provided by the classifier, it shouldn't be the official, you know, result, because never we can say our computer decided that you have this pathology. It doesn't work like this. No one can accept this.
At least now.
At least now, I don't know, yeah, maybe at least now. Yeah. So far, it's like this. But at least this system is here just to assist, it's just to help people. So that's why it's important you can understand the fact that this scheme, it works whatever the application you are working on. just imagine your application. You have this scheme, and you say, okay, first step is this one, second step, third step, fourth, and you should be able to make differences between inputs, outputs, depending on the different applications. Okay, so you can even make a kind of table, and you say, okay, this one is biometric for security, and this one for medical. Okay, and here it's like a dictionary that you can use. And for security, you say, when I talk about enrollment, you have to find another word instead of enrollment. When you talk about extracting features, maybe it's the same, extracting features. When you talk about matching for doing this, and you try to find something equivalent, you know. When we say we enroll one person, here we say we declare one pathology. Okay? So the idea is to find something equivalent, you know, to some different words that are used in the in security applications. Because behind this, you can understand that the different tools you will deal with are very often the same. Very often are the same. What you change just the words. So sometimes, even if you do the same, you know, the same procedure in terms of enrollment, feature extraction, classification, in the medical field, people, they forget completely that they are doing biometrics. And if you talk with some people, you say, I used biometrics here for the medical field. They said, no, this is not biometrics. Why? Because these people are very, very connected to security biometrics. That's why anything which is different than security, they said, oh, this is not biometrics. If the input is not, you know, a face, iris, they said, no. If the purpose is not to identify persons, they said, no, this is not biometrics. And I cannot agree with this. Why? Because just you compare. Just analyze this word and analyze also the scheme. And you can understand everything, that it's approximately the same. So at the end, what we need, in fact, maybe we need just a kind of dictionary table to say, okay, you guy, you are in the security field, so you will call this thing like this. I am in the medical field, I will call what you call in the security differently. And I can add other rows here. What can I add here? Security, medical, gaming, anything. Okay? And maybe here, you know, your dictionary will change. So, if you understand this idea of this dictionary, if you understand the general scheme that you have here, I think it's enough to deal with different applications. And you will understand that the skills that you have to develop are basically image processing, maybe electronics for the captures, and computer science. Okay, always you have to make difference between the goal that you want to reach. Okay, you have an application, and when I decide to create an application, I have absolutely to define the goal. What will be the purpose of this application? So when you define the goal, never ever you have to start with defining the tools. Okay, yeah, it comes later after this. Okay, when you define your goal, always you have to start with the structure of your application. Input, what you have to define: input, processing, output, processing, and so on. And you say, this is what I have at the beginning, and I want to transform it at something different, the output, the final output. That you have to understand that meanwhile you can pre-process in many steps your information. The input will provide an output, and the output will be the input of another system that provides another output, and so on. Okay, but once you have this, you can use, of course, the block diagram that we have shown before. Sorry. Okay, you can use this one, and after this you can define in each block the tools that you want to use. Okay, what I mean by this, you have the first block. Okay, let's do it like this. Pre-processing, feature extraction, database, decision. Sorry, you understood. And the output. So here it will be inputs. And once you have, it's always the same scheme, and you say, okay, now what should I do? What should I use as tool here? And you start describing. You provide your details. Here for the pre-processing images, the same. Here you start describing the tools. I will use, I don't know, Fourier transform. I will use high-pass filtering. I will use anything, segmentation, wavelet transforms, and so on. For feature extraction, you will define the tools. Okay. Including for database, you can define the tools. Okay. And after this, you say, okay, now I arrive to the last one, where in which I have to take a decision about pathology or anything. So how can I do this? What are the different tools I can use? And you have to decide which classifier you have to use. Is it possible to use neural network as classifier? Should you use Kamin's classifier? Is it enough? Do you need to use SVD, for example, machine learning, some different methods, you know? So here, you propose a certain number of tools. That's why the most important before describing the tools is to have this block diagram. It should be clear. There is something which is very important. Once you have your system will output a decision, okay? You have here a decision. Is it finished or not? Once you have the decision. Decision is provided by your system. So, I don't know, maybe the application is for security, or maybe this is for security, or maybe this one is for the medical field. Okay? Whatever the application, at the end you will have a decision. Okay? If it's for security, if you are using identification, you will have a name or group of names. You can have decision like yes or no. You can, if it's in the medical, it will be the same. The name of the pathology or any. But do you think that we stop here? At the same time, I just noticed one question. I would like to know when this is. So the question is, you can read it here. No, you cannot. I will read the question. So he said, I would like to know for one disease, for example, if the signature stored in the database is built by considering one person, he means who has this disease, or considering many persons who have this disease by extracting common points of each person. So can you repeat? Do you have an answer?
Actually, it should be multiple people, because one person maybe not represent accurate about the disease, but multiple common points of the same disease will be more accurate, I think.
In fact, when you want to train your system, especially if the purpose is to identify pathologies, as I said at the beginning, you have to observe many pathologies. And if you take just one person, he's not representative for the pathology. So you can decide to construct a database and to take many persons. Okay, a group of persons. Based on this, you can extract some features for a given pathology. So we can imagine one pathology. If you want to characterize it, you will ask many persons having the same pathology. And based on this, you will extract maybe one signature. And you will say, pathology number 1 corresponds to this signature. Because if you use only one person, he will not be representative. very often, if you want really to characterize one pathology, you need to start this first step. You use a database, and you extract one signature. Okay? I asked you a question before. I didn't forget. When you obtain a decision at the end, is it finished?
Because we have to study about false rejection and false acceptance issue also.
Good. So what? How we call this step? No, it's not verification. How we call this step? Pardon? Yeah. Pardon? Precision of the system. Evaluation, yes. Evaluation. Once you have decision, after this, the last thing you have to think about evaluation of your system. Is it accurate or not? Is it reliable? Is it, things like that. So always, whatever the application you are working on, at the end, you need to evaluate the performances of your system. It means it's like, for example, I will design a car, and I say, okay, now I have a car. Is it enough? It will tell me, no, I would like to taste it. I have to drive, and I will see if it's if I will be comfortable with this car or not. So the fact when you have a result to say, oh, I have designed the car, this is your result. This is your own result. It doesn't mean that it's good, that people will be satisfied. For this reason, evaluating performances of your system is very, very important. Why? Because you have to convince people. I created something, I designed something, I proposed one solution, so you have to convince them that you can use it, believe me. But of course you cannot say, believe me. No one will believe you. And I remember one day, it was one student in biometrics, it was I think 4 years ago. He did an internship somewhere in the research lab, and he obtained good results, and he came to defend his work, and he started presenting his work and different curves and signals and things like that. And during the presentation, very often he said, yes, believe me, it works, believe me, it works. And we said, okay, I cannot believe you like this. You are a kind guy, okay, but I cannot believe you just because you say, believe me, believe me. When you write a research paper, the same. You cannot say to people, I obtained this result, believe us, it's interesting. And the reviewers, do you think that they will congratulate you and they say good? No. So this is the idea of evaluation. You propose one solution, and you have to evaluate what you proposed, because this is the only way to communicate to the other persons, the performances of your system. Because it will help people to choose or not your system. So always think about, create something, design something, you can invent something, you are free. No one can tell you, no, you cannot do it. do it, but at least at the end, do provide an analysis, performance evaluation, evaluation of the performances of your system, because this step is very, very important. It's basically to convince the other people, the users. Okay? If I design a microphone, now I'm using microphone. I didn't design it, but I'm using it. And how can we evaluate? Because the one who designed the microphone in the technical sheets, they gave bandwidth, blah blah, everything. Based on this, I bought the microphone, right? Because I believed him. He said, yeah, this is a good microphone, good quality. But after this, I'm a user and I will use it. Maybe I will have another idea. Maybe I will agree with what he said, or maybe not. So you see, it's another evaluation. There is what we call the technical evaluation. So it's like the designer should do it for the other. And after this, users can evaluate. If you buy a smartphone, you can evaluate it based on your criteria, because you know what you are looking for. Maybe you are interested, you will in some smartphones, you can take two smartphones with exactly the same functionalities, and they look like everything is perfect, but maybe the charge time is not the same for different smartphones. For one of them, you need just 20 minutes, and for the other, maybe you need 1 day. So here you can see, as user, if this criteria is very important for me, I will pay attention to this point. Okay? Do you have questions? No questions? Is it clear? If I give you any application, can you project your ideas over some schemes? Especially the main scheme. If you have any application, normally you should be able to project, okay, to project your ideas, your project over a scheme like this. If you cannot do it, it means you didn't really understand your project and there's something wrong. Yes or no? Probably any project you can project it over this scheme, and it will be helpful. Why? Because once you do it, you project it over this scheme. After this, you will start describing the different tools. If there is something wrong, for example, you are not satisfied by the results or in the evaluation, how can you improve the performances? Directly, you can say, yes, performances are not good because maybe, I say maybe, this part is not good. So maybe I have to modify the tools I used, because you used maybe some approaches. So if you modify directly something here, you will see directly your results and your performances. And very often, and you will take some classes on evaluations, it's for sure, because you need this. Generally, we use some, curves. Okay, so these curves for security, very often we use the last time I thought FAR, which is, remind me, false acceptance rate and false rejection rate, and you can use the EER very often. You have curves like this, and this is the EER here, this point, okay, where you have FRR and FRR as are equal. Anyway, so any method you develop, you should provide some curves of evaluation based on some statistical studies. If you don't achieve any statistical study, believe me, people will reject your work. Always they say, okay, it's interesting what you did, but have you tested on a database? You say, yes, I've used the database, and they will ask, okay, how many? Always, it's... So if you say just the 3, people, they will say, are you joking? In some applications, when you present maybe around 10, 15, maybe it may be acceptable, especially if they know that the acquisition, for example, if it's very expensive, you need to do experiments, and you know each person, when you capture the data, the cost is very high. So maybe they can understand the fact they can understand the fact that database is a little bit small, but you have to explain why the database is small. But believe me, when you create or you propose or you design a system for the evaluation, yeah, the database should be should be very important. So don't play just with 2 or 3 or 4 persons. It's not enough. Okay. So, as I said, the evaluation, always very often you have some curves. It depends what you will present here as curve. And let me just, maybe I delete all this. So imagine that at the end you have your evaluation curve. People directly, when they see this curve, they will understand many things. But at the same time, when you do some analysis, you can say, okay, this is the performance of my system if you use as parameters alpha 1 equals 1, alpha 2 equals 3. When you set up your system, very often you have to modify the values of some parameters. But you say, if you modify the parameters, maybe performances will be different. So you can give many cases, you can explain how performances will change depending on the condition of acquisition. So it will give much more insight to the user or to the one who will evaluate your system. So sometimes 1 curve is not enough, 2 curves not enough, but at least you show when your system works. And there is something very important, and very often people they forget to do it. I will tell you what. If I ask you to design one system, you will work on it you will obtain your result, you try to evaluate it, and very often you try to show only positive things of your result, very often, including researchers. And sometimes they try to hide, I say they hide, the cases for which your system doesn't work. If you try to hide it, believe me, this is not good, because it's very important, you know, to highlight limitations of what you developed. Okay, limitations. It's important to say it works well in this case, this case, this case, but we noticed that in some cases it doesn't work for this reason, and this reason. So here, if you do it, if you show that it works in some cases, and maybe in some cases performances will decrease, because imagine here you have a parameter p, okay? And you say, okay, when you increase p, we can notice that performances are good, okay? And you stop your curve here. Why? Because you will not show the result just after. Why? Because if you show the result, it will be something like this. You know, no, I will hide it. I don't want to show this. Otherwise my paper will be rejected, otherwise my project will be rejected, and blah 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 blah, and so on. I think you have to do it because it's an information, it's an important information. At least you show when it works, when it doesn't work. Or sometimes you show just one segment of your results, okay? Because here it's horrible, you know, the result it doesn't make sense, and you publish just this result. So it's not very interesting to show when the performances are high, but it's also important to show when it doesn't work. So we call this limitations. Limitations of your system. I tell you this because you have to develop to work on some projects. So of course you will design, you will have results, you will evaluate your system, but you have to add limitations of your system. It should be clear. So avoid to hide, you know, some information. Okay? Is it clear? Any question? No question? We can take maybe a break. Okay? Okay, we take 15 minutes break and we come back. Thank you. Can you hear me? No, not you. I know. Okay, good. So, I will close this window. This one. Okay, good. So, let's see. Yeah, this is just another application of biometric, because do you remember last time when we said in biometrics we can talk about physical, biometrics or behavioral biometrics. So the same may be applied for the medical field or to any other any other field. So here, just it's an example to use biometrics in the medical field, but to highlight behavioral aspects. Okay, so look at this example here. So we have one user who is looking to this screen, and just maybe you can notice something in this screen. We have some spots. Okay, we have some spots, and we have here a camera. This camera will capture, of course, the face, and as region of interest will be interested in just the region of the eye here. You can notice this. Okay, so in fact, if I make a zoom on the camera, you will have an image like this. This is the eye, and this is the iris. Okay, so as I said, you have here a certain number of spots. Okay, and these spots, in fact, we can make a kind of program to make them moving. Once, for example, we say, okay, when you see a red spot, just look at it. Okay, imagine at the beginning this one is red, so this user should fix this point. When just few seconds after the spot moves to another place, for example this one, so he should look at it, and so on. So what we measure here, because in fact just the eye movements, because each time this person tries to track, okay, we say this is tracking. We try to track the spots, so there will be some eye movements. So here, what we can do, our region of interest will be this one, and we can focus on the central point, and we try to measure, for example, just the the eye movements. It looks like the project done by one of the students here, Hassan, last year. So in fact, we can at the end we can extract, a signal. So when you analyze your signal, you can see, for example, the iris is in this position, and after this during a few seconds, and after this the person is looking to something else, and so on. Okay, so we try to track the eye movement. Why? Because in some cases, in some examples, in some applications, especially in the medical field, some people they have some difficulties to track objects. You know? So imagine the spot will change like this. This is the input. And after this, you have the user who should track the changes. So maybe at the beginning, his eye will do something like this. Someone who is normal, we can record a signal like this. Each time we change the position of the spot, so the user tries to adjust the eye movement, and it will be like this. In some cases, especially in some pathological cases, people, you know, the transition is not the same. So when you change the position of the light, I don't know if I can change the weight. I would change the color. Where is it? Yes, I would change just the color. Oh no, it's still okay. I want to make it red. Now it should be okay. So some people, when you change the position, you know, transition may be something like this. Slowly he will change, you know. So can you see the difference? So you see, so this one is the reaction of a normal subject, and maybe this one is the reaction of an abnormal subject. So we have some application like this, you know, each time we change the spot, okay, and we try to track the eye movement. And here we can measure, we can extract some features. Can you tell me which kind of features we can extract from information like this?
The lag between
the what?
The lag
between the lag between
the change of the image and change of the eye movement.
Transition speed, Uttara said, yeah. And we can, if I try to make just a zoom of this, I would have something like this. So this is the change of the spot. Normal person will do this, and maybe an abnormal one will do this. So in terms of the characterization, you can do many things. You can say, okay, let's model this movement. It means I can extract some features, alpha 1, alpha 2, and so on. And let's model this one. And I will obtain beta 1, beta 2. So we can see shapes are not the same. This one can be approximated to line with given slope alpha. Okay? And this one, it's something different, so it may be approximated to this signal. So based on the information we extract from each signal, we can distinguish between two behavioral. This is given behavioral, this one is something else. So we can imagine many applications like this. You measure at the beginning, and after this you extract parameters, and after this you can say something about the behavioral. It's a decision, of course, and so on. So it was just an application in the medical field for eye movement tracking. Sometimes, you know what we do? Sometimes we can test applications for smokers. Or maybe some people who are drug addicts, okay, drug addicted. There are many studies like this. Why? Because for drug addicts, some smokers, maybe there are some changes. You know, when you want to track, you track a target. When I show you a region of interest, you will take time, you know, to go how to say, to track it and to find it in a scene. You have information in the screen, but you are not very reactive. The information is here, but maybe you need few seconds to detect this information. It's not like someone who is normal. Once you have a chance, directly say, oh, I saw a red spot in this region. For someone else, you give him an information and you have to wait a little to say, ah, yeah, I noticed there is something in this region, and so on. So the reaction may be very slow. So maybe for some people who are alcoholics, who you know, or if they are addicted to something, some substances, you know, their reactivity is not the same. And in some applications, we try to quantify this reactivity, especially to say, look, if you are alcoholic, your reactivity is not very fast, and we try to quantify this information. Okay, so this is another application of using biometrics, always bio and metrics. This is for gaming. And this is the device Xbox. So if I give you an application like this, look, and I tell you, okay, it would be a kind of exercise. And I tell you, can you project this scenario over the block diagram I gave to you? Okay, I mean, you know, the previous one. I mean this one. This is the generic block diagram. Okay, and now I have an application like this. And the question is to project this scenario over the block diagram. So can you do it? What can you propose? Maybe I try to make it clear. Okay. Pardon? Look, I will reproduce the block diagram here. It was approximately like this. So is there a way to make this application, you know, to project this application over this block diagram? Okay, tell me. How can we start? Capture which data here?
In this case, gesture analysis, we capture from traditional camera or fixed camera.
I have to remind you, and when you have a project, the first thing, what is the goal? What do you want to do? Because if you start with captured data, it doesn't make sense. So at the beginning, you have to be clear. What is the purpose of this application? The goal, normally, you should be able to explain it to anyone. Even if to the 10 years old kid, you will tell him, look, I will design a system and it will be able to do this, this, this. This is the goal. It should be clear and simple. So never try, don't say, yeah, I have to capture data, I have to capture motion, No, try to use just some simple words so that anyone can understand the purpose of this project. So I gave to you one Xbox or one sensor, I gave to you one screen, and I have user here. And I told you, based on this scenario, okay, imagine your application, and after this you have to try to make it as a real project. So first, tell me what will be the goal of this application.
The goal is to get to the movement type.
The goal is?
The movement type of the language.
Gesture analysis or identify the movement, identify the
Yes? Continue.
I think the goal is
Don't just give me words like this, movement. No. Try to make a sentence.
recognize the dresser of the user.
Pardon?
Recognize the dresser of
Yeah, we try to recognize
the dresser of the user.
users' gestures.
More technically,
Why?
to interact with the game.
To interact with the game. Okay? So we try to recognize users' gestures, and based on these gestures, we make them, all these gestures, interactive with a scenario of your game. Okay. So it's a general idea. And after this, if someone asks you, can you give more information? Someone, if you have in front of you a kid, and what will you tell him?
Start with the game.
You can maybe talk about the game, and you say, okay, do you like tennis? He says yes. And you will explain to him, okay, I will make you playing tennis with a virtual person. So on the screen, you will see someone who is in front of you. He's virtual, and he will shoot the ball, and you'll interact with him just by your hands, just using your gestures. Okay? And he will understand the general idea. So he's waiting for someone in front, and he tries to play with him just by doing some gestures. Good. Now, you as engineers, how can you, the same question, how can you project, this idea over this scheme? what will be the input here, what will be the sensor, the input, and what is the output I'm looking for. This is the most important phase when you create your project. If you don't know what is the input and what will be the output, you will be lost, completely lost. Okay? But if you have some blocks, you say the input is this thing, and you define each output at each level, things will be clear. This one is the database. Okay? So let me know about which sensor I have to use here. So I have to use a camera or... Okay, Kinect is just sensor equipped with a camera. Okay, equipped with a camera, and you know, you can have the infrared also, one camera, and yeah, good. So here the idea is to capture images. Okay, so you will capture images, and at this level you will obtain, you will get what? An image or sequence of images. Okay, so the idea is important to train your system. It's important to train your system to recognize different gestures. So think about the table I was talking about previously. Here I'm not interested in the identity of this person. I'm not interested if she's healthy or she has any problem, she has a pathology. This is not my... But here, the kernel of my system will be gestures. So this is what I have to identify, the gestures. So remember, when I used my table like this, okay, and we said this is for the security, this one for the medical, and this one for gaming, and I said here we have inputs. So here it should be the name of the person, and here is the pathology, and here is the name of the gesture. Okay, so we try to focus here. So my system should identify some positions of my arms, legs, and head, and so on. What will be region of interest? So you detect the body. Okay, first you will detect the body. So if you want to play tennis, probably you need, in tennis, maybe you can define 2 regions of interest, or maybe just one. Yes, if you use the left or the right, it's up to you. It's up to you to define the complexity of your game. But at least it's interesting to say, okay, the region of interest will be the arms. I'm not playing football, so in fact I don't need really this region of interest. So when you detect the human body, you have to define, of course, the region of interest. And here you can extract just the information you are interested in. Of course, we try to make it simple, but when you develop a game, you can make the algorithm much more complex to take into account other information and so on. But here, just we imagine it's a very, very simple game, because when you start your project, never try to make it very complex. Just try to make it simple, and after this you will add some functionalities, okay, to improve it. So here, as I said, you define your region of interest, and I would like to go back very often to where is it? Where is my slide? Yeah. Okay, so here I capture the image, and remember, in my block diagram I have the pre-processing, image processing. So in fact here in this step you have to define your region of interest, and you have to extract the region you are interested in. Okay, so I lost my where is it? Not this one. Yeah, it was here. So here, when you pre-process, in fact, at the end, you will have only maybe this information, only this one. So I can, after segmentation, after filtering, you will have just maybe this information. Okay? So you will have this information. What can you measure? To understand which movement it is. Is it possible with just one image? You need a sequence of images. So in fact you need many images. But at least if you pre-process each image and you highlight here the region of interest, you will do the same, you repeat the same program for the other images. And to understand the movement, you can propose one solution. So what can you propose? If in this region of interest you can say, okay, this point is very important, this one is important, and this one is important. Yes. If I do the same thing in the second, the next image, I will extract, okay, I will try to just look, I will extract this image. And probably you will have also something like this. Maybe in the third image, you will have something like this, and so on. So in fact, you can decide after this, the position of this point, okay, in the first image, the position in the second image, in the third image, and so on. So what can you do?
Get it as a signal.
Yeah, it becomes a signal. So you take this point and you have the second point, and you have maybe third point. And here you have time, of course. Because why? Because in each image you extract positions of interest. You have position alpha, beta, and gamma. Because you say, yeah, I need just these 3 points. The histogram of what? You can, if you want. You can say, okay, I observe my movement over time, and I will use an histogram. Why not? You can do it. But here you are pre-processing because you are looking for something, because you need what you want to do. You want to extract signature. Okay? This is what you are looking for. You observe. At the beginning, you see you pre-processed your images. And after this, you are looking to extract some features, right? So, what will be the next step? Okay, imagine we observe these variations. We have 3 signals coming from 3 points, and we see that these points are moving. Okay? So we can, as a training, you can ask a user to make a movement. You extract these features, and based on this, you can decide, for example, from this signal you will extract some parameters. It may be x1, x2. From the second signal x3, x4, and the last one x5 and x6. And we call this a signature. Okay, so the idea is to find a solution. You observe this information and you extract the signature. You characterize these signals. If you want, you can decide to use histogram, Fourier transform, anything, but at least at the end you said, okay, all this information will be characterized by this signal. Why? Because this one is, I will call it movement 1. Okay, so in your database, I should have movement 1. It corresponds to signature, right? After this, you change the movement. It will be signature 2, and so on. So what you can notice here in the table, we don't need the name of the person, we don't have the pathology, just movements. This is what we are interested in. So I call it movement 1, movement 2, movement 3, or motion 1, motion 2, anything. Why? Because at the end, I want to make a smart system to recognize all the different movements in the screen. Okay. Yeah, I saw some questions. We are interested in feet movements. Nitza, you said this. It is football. Who wants to play football? Okay, if it's football, it's not a problem. Just the region of interest will be just legs, and you do the same. And if it's another sport where hands and legs are, or arms and legs are involved, no problem. So yeah, just you detect all the region of interest, and in your table it will be movement 1, 2, 3, and so on. Okay. So if I go back to my scheme. So as I said here, from a sequence, okay, I pre-process my images, I extract features, and here in the table in database we have different movements, okay, that should be stored. So very often, if you want to extract a signature for a given movement, you can make a kind of training. You can repeat the same movement many times, okay, just to have something statistical. So if you are a player, you can imagine a system which says, okay, I need to extract features. So to do this, just repeat this movement 10 times. And after this, the system will say, it's okay, no. And he will extract the signature, and it will be stored in the database. Now, if you start playing, normally all the movements should be stored. Yes, it's like enroll. It's like you enroll all the different motions, possible motions. If you want to play tennis, so probably only motions with arms have been stored, but if you use any motion with your leg, it will not be taken into account, right? So here it's a kind of training, and here it's, if I call this training, this one it will be training and playing, right? So here I start playing, I will do a movement with my arms, and of course this sequence of images will be processed by the same block as previously. Okay. We extract exactly the same features using the same methods. And here, what we have to do, we start the matching or the classification. So we use one motion, and your system should say what will be the output here. Yeah, the name of the movement, movement number 4. Okay, so you will get information like this. So the system will understand that you did specific movement, and in your program you decide what you want to do with it. An action, yeah, it will be followed by an action. So if the movement is recognized, automatically there will be a routine, a function that will be applied, and to interact with the program. For example, when you do your gesture, you will see your ball moving from this side to the other side. Okay, so here I recognize the movement and I interact with the system. Yes? Do you agree?
Yeah, but this should happen in real time. This is the problem.
That should be human interface.
Oh, of course, it should. Yeah, in real time, and you know, in any application, even in security, you can imagine, yeah, in real time. You give your fingerprint and directly we say you are this person. You are in front of the camera. We can imagine in some airports, you know, we detect faces in real time and we can identify, but not for 100% for with good accuracy, but it exists some techniques like that. In real time, we try to recognize the person. So it's the same here. You have training phase, and you see here you have the matching phase. The output should be the movement, and this movement will be connected to your program to make your interaction, and you create your game. So what we did here, we projected a scenario. You know, I gave you just 3 entities. I gave you 1 sensor, 1 screen, and 1 person. And you can see that we projected all this scenario using the same block diagram as previous. So normally, we can imagine maybe another scenario. So if another scenario, I propose to you 2 or 3 objects, we can ask you just to project this in your block diagram, define the inputs, define the output, which should be the result. The output should be the result coming from a classifier. Okay, so for the training you need this part. And when you start applying your system, you have an input and you interact with this part. And these 2 blocks are connected, of course, with the database. You see? I know it's not nice like this, but if you understand it's okay. It's like Picasso, you know. When you see something you cannot understand, but when you focus and you can understand many things. So, do you think that you will be able, if I give you, imagine as an exercise, as an exam, it would be nice. In an exam, I give you just 3 or 4 images. Maybe I give you, I don't know, 1 person, 1 ball, and I don't know, 3 objects. You imagine the scenario and you project it on block diagram like this. Do you feel able to do it or not? What will be the first step? Good. This is what I was waiting for. Always I repeat. Believe me, if you forget this, if you start with image processing, it's like doing nothing here. So always make it simple. What do you want to do? Your goal. Design something helpful and useful, interesting. If I'm convinced, I can say, okay, let's do it. But if you start processing your images and you don't know exactly what it will be used for, believe me, you will struggle a lot. Why? Because you know, when you start programming, when you start proposing some approaches, it's like you will go in a universe and you will spend a lot of time, you know, lot of time. programming, solving problems of bugs, things like that. But at the end, you say, what I am doing, right? And do you imagine if you spend 2 years working on something, and there is just one kid who can say, yeah, can you explain to me what I can do with this system? And you start blah, 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 blah. And you feel inside yourself you are not convinced, even you. And here you can have some doubts. And believe me, this is real, because why? It's just because you don't know what you are looking for. I know many people working on some projects. Believe me, they don't know what they are really looking for. And if you don't have a goal, it's like someone who is in ocean, yes, or desert, or I don't know. And he's just walking or swimming or I don't know, and he said, I will see what I can meet as interesting things. It may be very complex because don't forget, we can talk about science. So it may be something very technical, but you have to understand people, they are waiting for you. Users. Even if you explain to them that you worked a lot during 3 years and you have one product, people, maybe if there is someone who spends just 1 week, he developed interesting application with clear goal to make it useful, interesting, and with perspectives. He can maybe convince the user to buy this application. So there is science, it's something, but think about the time. Think about energy. What else? And think about cost. You know? So many parameters are involved. And when you have an idea, you don't have to say, I have an idea and just I want to make it working. That's why you have to, if you are someone who is interested in industry and you have to develop some products, you have to think about what we call time to market. Do you know this? Time to market. What is time to market?
The time that's required between the very early idea to become a product.
Yes. You start with an idea, you make it a project, and you say, okay, when anyone, a user, can really use it. So this is the time to market, when you start until you make it really available for users. And this parameter, I call it alpha, you call it as you like. Believe me, It's very important. So the factor time should be optimized. That's why when you define your goal, as I said, never neglect the time, never neglect the energy, and never neglect the cost. Okay? Questions? Is it clear? Okay, good. So I hope just if one day just I give you just a scenario, so normally you should be able to project it using the block diagram I gave to you. And after this, once you have the block diagram here, of course it's interesting to work on tools. Sometimes you can develop your own tools. Why? Because you have your own skills. Maybe because you feel comfortable in programming. Maybe you feel comfortable in how to say, in image processing or something like this. And sometimes you need to work with someone else. Okay, you are good in image processing, but you are not good in computer science, in programming. So you can collaborate with someone to integrate, to program your code. And you have to communicate with him. Okay? So that's why you have to understand when you take different classes, sometimes you can be just wondering, you say, okay, what is the purpose of this subject, this class? You will see in very soon you will start working on face detection. Okay, face detection, and here you will see some methods, some approaches on how you detect a face, on how you extract features. It's very interesting, but it's at this level. You are here. Some classes will give you information, some local information, you know, to be used in some different blocks. And sometimes you take some classes to have this general vision, general insight. You need both of them. It's like you work at the microscopic level, okay? So sometimes really you need to see the details of details. Sometimes you should have large vision about what is going on. It's like if I don't know, you are interested in our galaxy, or maybe some people, they are interested on the Earth, you know, and they try to focus only on this, and some people, they try to see what is happening in the galaxy and also all the interactions, you know. So that's why it's important for you to say, okay, I'm here, or maybe it's interesting to work here, but from time to time I don't have to forget this. You know, it's a kind of multi-resolution. Always at the end you have a user. And when you start from scratch, sometimes you can start from scratch, and sometimes you can decide to start from another level, not from scratch. Why? Because at least you know that many things, you have your general idea, and you say, okay, this thing, I can find it here. This thing I can find it here. This thing I can find it here. So you integrate. Just you use this entities. And after this you say, okay, now I will focus on this part because I want to be an expert in this. You cannot be expert in everything. It's impossible. But it's important to know, to have an idea about your environment. So you can be expert in something, but at the same time, you have to understand all the connections between different ideas. And at the end, you can say, I am expert now in this thing, and my field is this thing. You understand how it works, but you say, but I am much more expert in doing this thing. Okay? So I did another Picasso. Do you imagine if I give this thing to a slide to someone? Do you think that he will understand? No one can understand except you. So it's important, to understand all this this story. And why? Because look at this slide, because sometimes when you look at any project at the beginning, it looks maybe complex, even very complex. But when you start segmenting this project to many small projects, you start understanding all the different parts. Okay? As I said, if I give this slide to someone, he will not understand anything. But maybe if I start just to say, okay, just I will explain to you why I did this, I did this, I did this, and he will start understanding, and he will understand this part, and he will start understanding this part, and so on. Okay? And at the end, he will say, finally, yeah, everything is clear. Even if the general vision, there is nothing. Even this movement, you say this movement, there is an information here. Okay? So, let's move. Okay. Yeah, this is another application, and in fact, have you ever seen systems like this? No? Probably you will see it in a few weeks. Today we are 12? 30. Yeah, probably in a week 24. Yeah, you will see this system, a real system. In fact, this one, it's called emotive. And this one is equipped by sensors here. You can see you have some sensors. I think 14 sensors. And each sensor will allow you to record an EEG. You know what's EEG? EEG. electroencephalogram. Okay. So in the EEG, so you have here what we call some channels. Yeah, excuse me, just I saw a question. Someone who says, as students, the channel will also to use suitable tools to perform our systems. Can you give us some idea? Yeah, what I said about the tools, if the tools are for image processing, okay, if the tools, because you need to use some tools, if it's image processing, you have to know how to detect objects. And here you will take some classes about detection, how to extract features. You will take some classes about feature extraction. Segmentation and image processing, normally, yeah, you saw this last year. I can maybe give you some basic documents just to see some simple techniques of filtering and segmentation and things like that. But each time you will take some classes and also labs, okay? And classification. Classification, it's also a set of tools, and you have different approaches. So you will take, you will see theory and practice. You will practice in MATLAB labs. So think about the tools for detection, for feature extraction, and for classification. So you will take some classes about all these different parts as tools. So I go back to what I wanted to explain. So here you have a certain number of EEG signals. We call this channels. The electroencephalogram will record your cerebral activity. It means we can have an idea about your state based on this signal. Okay? What does it mean? If a person is sleeping, we can see, based on the EEG, we can understand if the person is sleeping or not. If this person is dreaming, we can also detect different periods on the signal, and we can understand if the person is dreaming or not. Why? Because in fact, for sleep analysis, you have four states. Okay, we have 4 states, and we can make the difference between the different states. So a system like this, yeah, you can use it to record your activity. And if I ask you to project this system over the block diagram, the previous one, it will be easy. In which part I can project it? This one. The first part. So instead, using the all this system is like sensor. So for the capture, you will capture data. It will be in the first button. It will be here. Oops. let me okay. So you see here, it will be here, right? Sensing. What will be the the output? If I use the system emotive, pardon? No, the region of interest is not here. Absolutely not. What will be the output here? I'm not talking about the output of the system. I'm just here. The output of the sensing.
Multi-channels.
Yes, just here you have first channel, second channel, third channel, and so on. Okay? And after this, you can pre-process all these signals. I told you you will see it normally, this signal, next week. Next week or the week after. Why? Because currently I'm supervising a PhD thesis. And just I asked my PhD student, she will present to you this system. So probably she will make a demo. At least you see how it works. And in fact, the project is on biometrics. So can you imagine something related to biometrics using the EEG? Can you imagine a scenario? Because we want to use the EEG for biometric purpose. I said when you think, when you sleep, always we can record your EEG. Okay? So the idea is that when you think to something, the signals will change. When you focus on something, your signals will change. And we can also represent this information as an image. In the image, I told you we have, I think, 14 sensors. So this is your brain, and you have some sensors located like this. Okay? At an instant t, if I stop the time here, for example, I stop it here, I can measure the amplitudes of each signal, right? If for each amplitude, I will give it a color. For example, if the amplitude is very high, it will be red. If it's very low, it will be blue. What you will notice, you will have an image here with different colors. Maybe this part will be red. Maybe this part will be blue, and so on. You will have different colors. And remember, I told you this image is obtained at a given instant t. It's like I stopped the time.
One frame.
Yes, and you have one image about your brain, your activity, the activity of your brain. So we will have some colors. I will explain this to you like this, and you will see next week or the week after, you will see a demo, and you will try to make a correlation between what I say and what you will see. So here, if I ask this person to think about something, okay, you have to understand that some parts of your brain will be activated. So we can notice that here the amplitude will be much more important and other amplitudes will be low. So if I ask you to think about something in the past, or maybe to be concentrated on something, so probably we will see some images here. Okay? If I make this, you know, this is just one image, but if I visualize the image over time, so you will see like a sequence, and here the colors will change depending on what you are doing. Okay? So in fact, this is just an acquisition system, and after this you can imagine lot of applications using this. For us, we are using the EEG for biometrics. Instead using fingerprint, the idea is to define a password just by thinking to something. Okay, so I can ask you think about something, try to be concentrated, and you will see that, excuse me, just can I extend the time, because here I have, yeah, in 5 minutes it will be stopped automatically. Okay, anyway. We can talk about it next time in more details, but this is the general idea. We ask someone to think about something, so what will happen? Some regions of the brain will be activated, and based on the region activated, it will be regarded as password. In fact, you can even train yourself to activate some parts and to deactivate some other parts of your brain. It's like a biofeedback. The only thing we try to use it for biometrics. This is a research, okay? This is what we are doing. You know, as I told you, I'm supervising PhD students, and the next week or the week after, the week after, there will be a demo. Okay, you will see the system. She will show you the system, and she can make some demo with this system. So this is the idea is that we try to imagine a password, you know, and we can apply it to be connected to any system. It's a long story, of course, but at least you can understand if I ask you to project this scenario over the block diagram. Directly say, okay, the sensors will provide these signals, and after this I can extract features and I can store a signature in the database, and after this I can use the system by if I imagine any password and I compare it and so on. Next time I will give you more information, because I think that the system will be stopped automatically. That's why I don't want to continue talking, otherwise it will be it will cut very soon. So yes, just the last thing before I finish. Tomorrow, I will meet students here to talk about projects. So for online students, projects, the proposed projects. So I think tomorrow you don't need to be here with us in real time, but you will get all the information by email, because you have absolutely to start thinking about your project. Okay? Good. Any question? Maybe in few seconds it will be stopped. No? Okay, good. Thank you. Thank you very much. And see you soon.